The Sun. A glowing ball of gas? Or a simple source of light and heat? The Sun is much more. It is the engine that powers the life of every single living organism here on Earth. It is a cosmic laboratory where nuclear reactions of unimaginable power take place. In the course of this video, we will take a journey through the fiery flames of its surface, explore the mysteries of its cycles of activity, and discover how this immense thermonuclear furnace sustains life on our planet. So settle in and prepare to be illuminated by the fascination of our Sun. What is the Sun? The Sun, a glowing ball of gas, is the closest star to us. Yes, a star like the vast majority of those bright dots we see every night in the sky, but much closer to the Earth. But how come the Moon and other planets like Jupiter or Saturn that seem to shine brighter than stars in the night sky are not also stars? Because stars emit light of their own, planets, and most of all the Moon, however bright they may seem in the night sky, do not emit light of their own but only reflect the light of the Sun. The Sun might appear to be the biggest star, but that is only because, compared to other stars, the Sun is very close to us. Only 150 million kilometers. That might seem like a lot, but it's not. We said in a previous video that the Sun's light reaches us in about 8 and 20 seconds. In the vast majority of stars that we see at night in the sky, their light reaches us after several years, and for many of them we are even talking about millions and billions of years. To understand this, some of the stars we currently see have not existed for a long time, but their light has only just reached us and we can admire them as they were in the past. We could thus call the night sky an enormous and fascinating time machine. The enormous power of the Sun. The surface of the Sun, or photosphere, has a temperature of 5,500 degrees. But as we approach the core, the temperature continues to rise exponentially to over 15 million degrees. If we could take a pinhead-sized piece of the Sun's core and transport it here to Earth, we would have to be at least 140 kilometers away from that tiny heat source to be safe. But the Sun is not always the same. It has an 11-year activity cycle, during which the number of sunspots increases and decreases. These sunspots are areas of intense magnetic activity, called cold areas of our Sun, which reach a temperature of 4,000 degrees and can cause solar flares and solar winds. Their size can vary greatly. Some flares are only a few times the size of planet Earth, while the largest can extend millions of kilometers into space. These phenomena can have a significant impact on the Earth, give rise to exciting atmospheric phenomena, but at the same time affect our climate and cause interference with satellite communications. Every second, the Sun produces an amount of energy equivalent to that of 6,000 billion atomic bombs, such as the Hiroshima bomb. How does all this happen? In the central part of the Sun, 600 million tons of hydrogen melt every second to form 596 million tons of helium. Where do the missing 4 million tons end up? They are transformed into energy, thanks to the most famous equation in all of physics. Only the 20th part of this 4% that is dispersed in space reaches our planet, but it is more than enough to make life possible for all living organisms on Earth. But the sun's energy comes to us not only in the form of heat but also light. The amazing thing is that the sunlight we benefit from right now was produced at the center of the sun thousands of years ago. In fact, when energy is released in the form of protons inside the sun, these are highly energetic and bounce back into the sun thousands of years later. So the light we benefit from, during a day at the beach for example, was produced by the sun even more than 100,000 years ago. How big the sun is. The sun is so big that it could contain 1.3 million planets like the Earth. Look how small we are. But is the sun a particularly big star? No, astronomers call it a yellow dwarf. This is because there are stars immensely larger than our sun, such as Stephenson 2-18. To give you an idea, this is our sun, and this is Stephenson 2-18. This star is 10 billion times bigger than our sun. If it were placed in the place of the sun, the Earth would be in it. It would also include more distant planets such as Saturn. How the sun came into being. The sun was born about 4.6 billion years ago from a cold cloud of dust and gas, known as the solar nebula. This cloud, due to the intense force of gravity, began to collapse in on itself, forming a central body called the protosun. Over time, the protosun began to produce energy through nuclear fusion, becoming the star we know today as the sun. Subsequently, the sun's enormous mass deformed the very fabric of space-time by literally bending it and imprisoning the Earth and the rest of the planets in our solar system in their current orbit. To give an example, look in the following pictures is what happened. The sun and life on Earth. The sun plays a fundamental role for life on Earth. It produces the energy needed for photosynthesis, a process in which plants convert carbon dioxide and water into oxygen in the atmosphere. This process is the basis of the food chain, as plants serve as food for animals, which in turn serve as food for other animals. The sun influences the Earth's natural cycles, such as the day-night cycle and the seasons. These cycles in turn influence the behavior of living organisms. The sun contributes to the greenhouse effect, a natural phenomenon that retains heat in the Earth's atmosphere and keeps the Earth warm enough to support life. The human body uses solar energy to produce vitamin D, essential for healthy bones. We traveled through the universe, exploring our nearest star, the sun. We marveled at its power and imagined its flames. We discovered how its warmth and light are crucial for life on Earth, how it affects our natural cycles, and how its proper distance from Earth is crucial for our existence. But remember, the sun is only one of billions of stars in the universe. Each star is a world of its own, with its own secrets to discover. So, keep looking at the sky, asking questions and searching for answers. The universe is an open book, and we are only at the beginning of our journey of discovery. Thank you for watching. If you liked this video, leave a like, share it, and subscribe to the channel to receive more fascinating content like this.